Hey guys, Jim Vanosky with Manufacturing Talks. You know, there are a lot of people doing a lot of things in manufacturing with an eye toward green and net zero and CO2 reduction. And a lot of them just seem to take the approach that whatever I do, people are just going to buy or sign up for because it's green, and ignoring that costs and, difficulty of implementation all kind of have an impact in the manufacturing world. Well, I'm really excited today because I'm joined by a guy named Ryan Gilliam. He is co-founder and CEO of a company that's working on green cement. And, I'm going to be honest, I went in with a little bit of hesitance and I really like what I'm hearing around his approach. And I think you'll like it too. So Ryan's going to be with us here in about 30 seconds. Stay tuned on Manufacturing Talks.
Welcome to Manufacturing Talks with Jim Vanosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
Hey, everybody. Welcome back to Manufacturing Talks. I'm Jim Vanosky, your host. I'm joined today by Ryan Gilliam. He is CEO and co-founder of a company called Fortera Corporation, and he's here to tell us all about it. Welcome, Ryan.
Great, Jim. Thanks for having me on.
Thanks for being on. Yeah, exciting stuff here. You're going to talk to us about clean cement. But before we do that, why don't you just tell us about your background, how you got doing what you're doing today?
Yeah. So my background, I was that guy that thought I was going to go the academic route in life. I did my PhD in materials engineering and was focused on, throughout my PhD on clean energy, looking at different electrochemical technologies. And so after I was finishing that up, I was planning to go the academic route, got called by a startup company in California saying, hey, look, it's a free trip to California. Why not come out, just see what we're doing? And,
Nice.
before I left California, I signed an offer letter and said, you know what, I want to make a go at seeing, can I have an impact in the industrial world? And initially thought it would be a 1-year endeavor, and kind of fast forward, I've been now 16, 17 years in the clean tech space, founded multiple companies. And it's really always been from a viewpoint of looking at old industries before really CO2 and energy efficiency and everything else was really a focus. And so it's been from that view of knowing what we know now, what would you do differently to try and solve some of these challenges?
Mm-hmm. Cool. Yeah, so you've worked for a few different companies before you co-founded Fortera, right?
Yeah, and actually, Fortera is almost bringing it kind of full circle. So
Mhm.
when I moved to California, it was to join a company called Calera. And Calera was the first CO2 to products company, or really the first company looking at taking CO2 and turning it into a cement product and solving the CO2 in the cement space. And, what I would say was it was an incredibly successful company technically. We figured out how to make a new type of cement where we're actually capturing CO2 into the cement itself. It was 44% by weight CO2.
Mhm.
Unfortunately, it was also a company that was at the time, and this is Clean Tech 1.0, there was a view that people are going to pay for CO2 to solve, the CO2 issue. And that's what would drive adoption and drive economics. And so it really wasn't successfully from a business perspective. And I actually took over that company as CEO, pivoted into another sector, into chemicals and into some of the other technologies we had developed. So shut down that CO2 to cement business back in 2014, 2015, and then also got into companies in the green hydrogen space. So really looked at a range of different things in between energy, chemicals, materials, and cement. And so with Fortera, we co-founded that in 2019, really ramped up in 2020. I think we opened our first lab the week before COVID. So just great timing in the world.
Right.
But we founded that really because what we figured out in this space, and this is the hard thing with clean technologies, is that if you want to have a meaningful impact on CO2, you're typically talking high capex, low margin, very large industries. So scalability matters. And the learnings we had with these other companies is that actually figuring out how to work within the ecosystem, work with the incumbents, use what they do well, that's how you can make the economics work at scale. And so Fortera is, yes, we started in 2020, but it has its roots in that original company. So the benefit is that 100,000 hours of R&D, those 100+ patents, the 5 years of piloting work we did, making hundreds of tons of material, putting it into real world projects, we were able to leverage all of that, leverage that technology we had proven out, but now do it at Fortera in a way that actually worked within the existing cement ecosystem to make the economics work. And that's really what drove myself and my co-founder to start Fortera.
Yeah, so that's all intriguing, and it's interesting to hear you talk about that kind of realization as you worked forward. Certainly working in a commodity world, you've got some constraints there that you have to live within, right? So then, as we look at what you guys are trying to do, and you mentioned it, you've got this enormous legacy industry that essentially you're trying to disrupt in a very good way. And so let's talk a little bit about, what are the drivers of the emissions and the inefficiencies, and how do you then start looking at tackling those?
Yeah, and so maybe to help level set. So cement, first of all, cement is the glue in concrete. So
Yep.
Once you take that cement and add your sand, your aggregate, or your rock, and your water, you get to concrete. Concrete itself is the second most consumed thing on Earth behind water. It's about 8% of the world's CO2 emissions. So obviously a big problem to tackle. The challenge is, though, if you really look at when you break down concrete and the CO2 and where that comes from, 90% of it ties back to the making of the cement.
Mhm.
The reason why cement's so CO2 intensive is that 80% of the feedstock to making cement is limestone. So every cement plant is basically located at a limestone quarry. Limestone is calcium carbonate. It's 44% by weight CO2. So that limestone, when it's put into the kiln, so when it's quarried, crushed, ground, put into the kiln at high temperature, it turns from limestone into lime. That's really kind of that active ingredient on the cement side. And that means that 44% of that weight of that calcium carbonate is lost to CO2 emissions. So when you break down the CO2, about 60% of the CO2 comes from that, what they call process or chemical emissions, that breakdown of that limestone. The other 40% come from the fact that you use hydrocarbons, so whether it be coal or natural gas or other fuels, to heat up that kiln.
Mm-hmm. Yep. Okay, so now you've got a company looking at all those emissions and the associated kind of inefficiencies from a manufacturing perspective. How do you start tackling those?
Yeah, and that's been this 16, 17 years in the making to get to the technology we have.
Yeah. Yep.
So again, it's in traditional cement manufacturing. You're taking limestone as your main feedstock. You're putting it into that kiln. You're decomposing it to the lime. You're losing that 44% of that weight to CO2 emissions.
Yep.
What's interesting is if you actually look at how nature forms its building blocks, if you look at coral reefs or shells in nature, the opposite happens. You actually absorb that CO2 and make a reactive form of limestone that's actually cementitious. Now, it typically only exists in nature for a fraction of a second, but that's how nature forms its building blocks. So what we figured out was how to take the natural process of forming its building blocks, where you're actually capturing CO2, and do it in an industrial way. So how can we scale it? What we figured out was how we can scale that up, do it in large volumes, do it economically, do it so that we make these reactive carbonates that are shelf stable, so that you can put them into a cement silo or cement bag, and they're only going to then react when you add water to it. So what we make, kind of see it on the camera here, is basically just beautiful white powder. This is 44% by weight captured CO2. And so this material, the benefit of it, it really can work within the existing cement concrete ecosystem. So we can already put it as blends with traditional Portland cement. And so these blends fit under the existing ASTM regulations. We had the ASTM regulations adopt our product for that. So you can put it to that product to market now. But the benefit of the materials, you can also go all the way to 100% our material as the cement. And when you go to 100% our material as the cement, that means you now have a cement that's 44% by weight captured CO2. And so the benefit on the CO2 side is really twofold. One, it's the fact that all those process emissions on CO2. So for us, we're still starting with that same limestone, that same feedstock of the cement plant,
right?
We're turning it into lime, but then we're using that to recapture that CO2. So I comically say sometimes we're basically taking limestone and turning it into limestone.
Right.
Going from an inert rock to a highly engineered form of limestone that's actually reactive and cementitious. And so the benefit there then is that 60% of CO2 that's typically lost to chemical emissions, we don't have. We save all that CO2.
Yep.
And then also, if you still use the same hydrocarbons at the kiln, because we're now almost doubling the weight of the product, that 44% of weight that's typically lost is back in as product. We're also more efficiently using the fuel in the kiln, so we also
Yep.
save CO2 there. So if you still use the same infrastructure, the same same fuels that already exist in this industry, you're 70% lower per CO2 per ton of our product versus traditional cement. And then there's obviously a pathway as well. And I think most things in the green space require green energy to make them green. I think that's one of the unique things about what we've done is we have the ability to get to 70% lower CO2 using the existing infrastructure. And then as green energy becomes more prevalent, as it becomes more cost effective, as it gets to higher capacity factors, we can also integrate that and get to a zero CO2 cement product.
Yeah, that is fascinating. And I find it especially interesting how you're approaching it from that capture perspective. So where those emissions are occurring, you're essentially just pulling those back in. Now, one thing that you kind of referred to there a few minutes ago, and you tout in your materials online quite a bit, is that you're bolt on for existing producers, which is huge. Obviously, anyone in industry is going to see that and really spark to it. So talk a little bit about, you had talked earlier that you worked with the existing producers. Clearly that was a value you had going in, and how did you achieve that?
And I would say it's a value that we've gotten to really by understanding what these customers really need.
Yeah, perfect.
I think that the fundamental challenge, and this is something that when I started out in clean tech, and I've done multiple of these companies now, there's always this comforting complexity, I think, in the new tech startup world, where you invent these new ideas, and the more complex, the more interesting they are, the more people like it and invest in it. The challenge really when you get down to it, though, is that's great if you have a nice, complex technology that's really differentiated in IP,
Yep.
but it really doesn't make it easy to integrate within the existing ecosystem. And so the challenge is, it's how do you develop your technology so that you can leverage that $1 trillion worth of capital that's already in place. And I think that the part that's missed a lot is, there's a lot of things that we can do with our technology where if we actually integrated with the cement plant and use their waste heat, we could get to even better operating costs. But these plants are already operational. They're making money. They have commitments with their customers.
Right.
So the idea that they'll shut down for 6 months a year to do retrofits, it's a really hard leap to make that actually happen.
Yep.
So we purposely have designed our technology where we are bolt on, in that we are adjacent to their plant. The only thing we need to do is tap into the kiln during any type of routine outage. We'll tap into the side of the kiln to be able to pull the CO2 over to our process, and we return back what we don't use. Same thing what we did at our first plant in Redding, California. If you went to the plant, you'd see just a hole in the side of the kiln where we're pulling CO2 over, and another hole a little bit above that where we're putting it back in.
Yep.
But that really is by design in that, so we can build our plant, we can go through that timelines for construction and everything else, not impact any of their operations. And then when we're ready to run, really just open up those valves and start pulling CO2 and giving them product back. And I think that's the part that is really hard to understand of how you fit in these big spaces, is that these plants that already exist, the capital's been sunk. So you're always comparing versus a company that's already making material, capital sunk, they're just paying OpEx. So you need to figure out, with a new technology to get people to adopt it, how do you get to a capital cost and an operating cost and not impact their operations that is something that they want to adopt and can be, again, be economically competitive. And that's really why we got to this thesis that we have, is that if you look at our technology from beginning through to end, we use their exact same feedstocks they already have at their plant. Our only feedstock is limestone. They're all at the limestone quarry. We're able to use as much of that capital infrastructure from quarry through to kiln as they have in place to be able to reduce our capital needs. And we were able to then put our material in blending with them so that we can use all their logistics and sales on the back end for distribution as well. So it's really through leveraging what they do really well that we're able to reduce our costs and be competitive.
Well, and so let me stop you there and just sing your praises, because it's been one of my constant headaches with the whole approach. And let me back up a step further. I've been in manufacturing my whole career. Manufacturing has always been about reducing costs, being more efficient, and in some ways that should march in lockstep with reducing emissions, because that's a form of waste. And yet across the spectrum of green this and green that, you see people who don't take the approach that you did, what you just talked about, around understanding that people have invested capital and they're in a functioning business that's making money, probably not a lot of it, right? Probably tight margins. But now you come along and you say, you've got to add all this additional capital equipment. You're going to layer on costs in your operation, and somehow people are just going to come flocking to you because you talk the green talk. It's such a wrong approach from a business perspective. And you guys coming in and saying, yeah, you understand that, and you're going to work with folks to say, here's a solution that isn't going to take you down, isn't going to cost you a bunch of money, and in the end can make you more efficient. Well done. That's
Well,
all I
thank
have
you.
to say.
Well, and to be quite honest with you, I mean, this is why I've been really looking forward to this as well, because I know with your background in manufacturing, I think that it's really a hard thing in venture. And look, I have a lot of battle scars and bruises from trying to do it the other way. And the thing that I think that, again, that people miss is that when you're a smaller startup company bringing a new technology forward, having a sexy technology that could completely change an industry and all that, I think gets a lot of attention, and it can get a lot of press, and it can raise money, and that's
Yep.
great. And I think to bring new technologies forward, you need stuff like that. The challenge that I've seen time and time again is that next leap, when you go from being a pilot plant and smaller amounts of investment in a startup company to really having to figure out how you get through to scalability, and how do you make logistics work, and how do you get
Mhm.
competitive on costs. A lot of things, that's where they fall apart. And so
Yep.
really for Fortera, the reason why we founded Fortera is that we knew we had an ability to, again, to fit within the ecosystem and leverage what is already being done so well to drive down costs. That's why we found this, because really from a company perspective, it's about economics and scalability first. And the great thing on the backside of it is, yeah, it's really good for the environment too. We'll solve
Right.
CO2. But the leading thing that we do with the cement companies is not from the sustainability angle. It is from the fact that we can make a product. The product more efficiently uses their quarries, because you're getting a 1-to-1 ratio. For every ton of limestone they quarry, we actually make 1 ton of product. They can make margin still on that product and get with that increased capacity. So turning that CO2 actually into product, again, makes more product on the back end. They have a chance to make more money in doing that.
Yeah.
So it's all of those that are really the drivers for them to do it. And then the great thing, obviously, is this can also help on the CO2 side piece of it.
Yeah. What a great story. Now you've been at this a long time, obviously, and you have your pilot stuff running. Do you have it in commercial operation yet?
Yeah, so we did a ribbon cutting earlier this year on our first larger we call a small commercial plant. I
Mhm.
think if you saw the plant, what you'd see it as it's a large plant. In probably most other sectors, it would be considered a commercial plant. In the world of cement, where you're typically talking million-ton plus a year, it's small in the grand scheme of the cement world. So it's a 15,000 ton per year plant. To put that in perspective, we basically directly capture about 6,000 tons of CO2 directly into product. And if you take the offsets also from fuels, upwards of 10,000 tons of CO2 saved relative to if you were making traditional cement. At 6,000 tons, I think it's one of the largest CO2 capture plants active in the world.
Wow.
Definitely one of the largest industrial mineralization processes in the world for taking CO2 into a product. But it's small relative to where we're going. And so this plant, the benefit is it's really proved the scalability, it's proven out what we can do on economics. It's giving us now enough material that we can put it out into real world demonstration projects to show how it works, to show the range of different products we can do with it. And it's really just, this is the hard part of getting through first of a kind. This is the needed plant to show that it is scalable and economic to drive that business development to get to commercial plants. We now have a considerable number of commercial plants, and for our commercial plants, we're initially targeting roughly about 400,000 tons per year type plants, because we're going to do part of that material as a blend and part of that material as pure product. But we have a number of those now under contract or under MOU, and we're into the definitive agreements to get through to contracts on those. And that's, in the US, that's places that really have CO2 and other benefits like Canada and Europe. We're trying to leverage places that have incentives in place to help with early adoption. So just like wind, solar, electric vehicles, having incentives in place helps with that early adoption, just helps makes the economics that much more attractive. But the benefit of our process, we know, is that it can also be cost competitive without those incentives. And so we're also then looking much broader than that as well.
Yep. Excellent. I should have asked this earlier. So product to product, the stuff you're making is essentially the same as what the legacy industry would have made?
So the actual composition of the product is very different. So reactive carbonate.
Oh, okay.
But what I would say is that from day one, the view has always been, and this is kind of, again, fitting within the existing ecosystem, is that cement plants, very large, 1 million plus tons a year. These are $500+ million type investments. From there, you then get to concrete. And so at concrete, these are much smaller investments. There's a number of concrete players, typically for every cement player, putting it out to the market. And then at every ready mix level, you have then now a lot of contractors using it. The hard part about bringing a new material to the market is you really don't want to have to go all the way down the value chain or down the supply chain to those end users to have to retrain them how to do it. So for us from day one, it's been about making sure that when we add our material in as a blend, so if we do it under the existing ASTM 595 regulations and do these 15% blends, that we match the same set time, the same flow rates, or really workability, and the same strength development as traditional Portland cement. What we've shown the industry, and this is why we're getting a lot of great collaboration with some of the ready mix companies, is that we can use our material to actually solve for specific pain points they have. There's a trend in the industry to go towards fly ash and slag and calcined clay and other additives, or what they call supplementary cementitious materials, into cement to reduce clinker content, reduce CO2. A lot of those come with different potential, challenges on the product, whether it be low early strength or flow issues because of water demand. And so we can engineer our product to really solve for some of those. So I think that that's really the benefit of a blend with our product, is that we can help solve some of these specific pain points. But again, it's been from that view of making sure that as people use our material, aside from seeing that Fortera fortified or React label on the bag to indicate it's greener, they're not really going to know that they're working with something different. When we go to 100% our material, this is where I think it's going to be interesting to see how the industry evolves. We are working right now to make sure that we can match the same type of flow rates, workability on our 100% material. But we do have advantages where we can get to higher strength or faster full strength gain or better set times. So trying to understand what the industry would want out of potential value adds out of the performance, that's still a discovery process. And what we do have as a company, one of our core values from day one has been think customer. And it's all about really getting material into customers' hands to get that feedback loop happening, to really learn and understand what is the right products to put to market.
So as a total aside, have you been following the news on the discoveries around Roman concrete?
Yeah, I feel like that every few years those come back to another set of articles out there.
I just saw one earlier this year where some researchers are saying that they've identified that it's cooked limestone inclusions that make that concrete self-healing. So, there's a little free nugget that you guys can look at in your spare time there in the lab around maybe a marketing point.
And and I have to say that that is the fascinating thing about cement and
Hmm.
concrete is that this is such an old industry. I mean, concrete, we say cement because we're really more in the cement space, but really
Yeah.
concrete
Yep.
creates civilization. I mean, everything in our built environment is done through concrete. And the fact that we're still really learning how the science of it works, what the chemistry really is happening, I think is fascinating how much of it has been used and yet we're still learning on it.
Yeah. Learning and relearning stuff that was done
Yeah.
2000 years ago that we can't quite recreate. Yeah. It's really amazing to me as well. Okay. So you've talked a lot about what you've done and a little bit about looking forward. As you chart out the next, say, 5 to 10 years for Forterra, what do you see coming down the pike for you?
Yeah, I mean, the mission for our company, and actually I have it right across the whole wall of the company, is paving the way to zero CO2 cement. And for me, that means in order to have a meaningful impact on CO2 in the space, we have to roll out the technology as broadly as we can. We're not aiming to build a few plants. And while that would make us obviously very successful as a company to build a few large scale plants, it really is about rolling it out broadly. And so we're in discussions with a number of players, in multiple different regions, geographic regions, looking at how best to build the business models, how best to bring in project financing, and how best to do project execution to get these done. As a company, a lot of the key hires that we've had over the last year and the way we're building out our team now is to bring on people in the project finance and the project development side piece of it. We have now a number of plans under MOU, and we're in definitive agreements on a number of these plants. We've already started looking at our first full scale plant from the engineering side and from the site side. So I think what you're going to see, and this is maybe just another reality check, which you'll know from being in the manufacturer. A lot of people, when they talk about going to commercial, they have really short timelines in it.
Right.
To go through the permitting, the feed package, or the engineering, phase of it, and then the procurement construction side, these are really 3-year endeavors. I mean, as you get to more and more plants, maybe you can bring those timelines in.
Yep.
If you have challenges on permits, obviously those can be even longer.
Yep.
So if you take the next 5 years, we will have a lot of commercial plants in that construction phase. We should have our first few up and online as well. But that really is the goal of the company now, is to build out that capability as a projects company to do a number of these plants.
Okay. Well, I wish you all the luck in the world. Like I said, I think you guys have a great approach and a great story, and be interested in following it and seeing where you take it from here.
It's definitely, it's been fun to date. I love seeing how much the industry has moved. I would say 15 years ago in the original company, it was hard to get attention from the cement concrete world and wanting to do something different.
Yeah.
I'd say now they all are actively looking at these different opportunities. And so by bringing an opportunity to the table that's economic and fits with what they do, I think that there is a lot of interest in moving stuff forward. So
Yeah.
I have to say I'm fairly optimistic on the space, and based off of the interest we've had in the space, that there's going to be quite a few fun years ahead as we roll out this type of technology.
Yeah. Well, I'm no insider, but as a longtime industry guy, what I'm hearing says to me you could be a big hero for a bunch of people. So good luck with it. Thank you, Ryan, for being with us here today.
Awesome, Jim. Thanks so much. Great conversation.
Yeah, same here. And Ryan brought us some stuff that was just utterly fascinating from a manufacturing perspective, and future technology for a legacy industry. All our guests bring us fascinating stuff. I can't promise it's all going to be as fascinating as what Ryan brought us today. It's all going to be fascinating. So thanks to you guys in the audience. We're here every Tuesday, and now sometimes even on Thursdays, as people love to get on manufacturing talks, and we love to have them. So keep an eye out for our next episode. We'll be here with more fascinating stuff. Thanks again for Manufacturing Talks. I'm Jim Vinosky signing off. So long.
Thanks for tuning in to Manufacturing Talks with Jim Vinosky. Watch for new episodes dropping every Tuesday. And don't forget to like, share, comment, and subscribe.